So here, once you type up this DAX code for this EPS column, just press enter. You see this new column appear as part of this quarterly income table. All right, and there's a kind of symbol in front of this column indicating that this is a calculated column. All right, for this column to work, we need to make sure, although this is already taken care of by Power BI, but just consider this intuitively. All right. For example, if you want to find the EPS for Apple on March 31st, 2023, you need to basically get the net income after taxes data from the income statement, which also corresponds to Apple on March 31st, 2023. You need to have that particular row from this income statement table, all right, representing Apple on March 31st, 2023. Okay, then use that number and divide it by this number, which is retrieved from the balance sheet, okay, the common stock shares outstanding. That number in the balance sheet also has to represent Apple on March 31st, 2023. You basically has to have those two rows aligned perfectly with each other, okay? They both represent Apple on that particular day, March 31st, 2023. Only in that case, when you divide these two numbers, okay, when you divide the net income before taxes, after taxes, by the common stock shares outstanding, you will get a meaningful number which represents Apple's earnings per share on March 31st, 2023. Okay, so basically these two tables, the quarterly income table and the quarterly balance table, has to be aligned based on those two dimensions, the stock symbol as well as the date dimension. All right. Once those are aligned, then if you take a row from the quarterly income table, for example, if that row represents Apple on December 31st, 2023, okay, that row is gonna be also directly linked to this quarterly balance sheet table, all right, and the row in that balance sheet table is gonna be representing Apple on December 31st, 2023 as well. Okay, only in that case this ratio will make sense. Okay, so that already, okay, that part of this perfect matching alignment is already taken care of when we construct this data model. All right, if you go to this model view, you can see the income statement and the balance sheet. All right, they are connected. They are not directly connected, but they are connected through this data dimension. So a particular row in the balance sheet, okay, is going to be matched with another row in the income statement based on that they have a matching date. All right, so that makes sure if you take a particular row from the quarterly income table and you divide it by another row from the balance sheet table, okay, these two rows are perfectly matched. All right, so you're going to basically dealing with the same stock on the same date. All right, using information about this stock's net income after taxes and this stock's information about the shares outstanding on the same date. So when you divide the net income by the shares outstanding, you will get the EPS for that particular stock on that same date. All right, so that makes sense. That makes this calculated column actually works perfectly. All right, that's because of this perfect alignment between these two tables, this quarterly income table and the quarterly balance sheet table. Okay, they have this perfect alignment based on stock symbol dimension and the date dimension. Okay, that makes this calculated column work perfectly without you need to worry about this alignment between the rows.